بسم الله الرحمن الرحيم. In this lecture, we are going to speak about the homogeneous linear equations with constant coefficients. And we will deal with the second order differential equation and how to find the solution or the general solution for the second order differential equation. As we stated before, the linear differential equation, it has this form: a sub n y, nth order, or the nth derivative for the variable y plus a sub n minus 1a, or the nth minus 1 order, equal to 0. If the right hand side equal to 0, we call it homogeneous differential equation. And when the coefficients are, all of them are constant, and this will be the special case for the linear differential equation, because the general case is a of x, y prime, or y second prime. But sometimes we can deal with the constant coefficient for the derivative terms. So in this part, we are going to speak about the differential or linear differential equation with constant coefficient, or the coefficients are constants. And to find the solution for this one, just explain the idea or we are going to use the second order differential equation, which that can be written as a double prime plus b y prime plus c y equal to 0. The coefficients a, b, and c are constants. Constant means real numbers. Now, if we try to replace y by e to power mx, then we are going to have m squared, because if we just, the first derivative for this one will be m e to power mx. Second derivative will be m squared. So replace y prime and y prime by this in the equation. We will have a m squared e to power mx plus b m e to power mx plus c e to power mx equal to 0. We take e to the power mx as a common factor. Then we have equation that is inside the bracket, which is am squared plus bm plus c equal to 0. We call this equation auxiliary equation of the differential equation. It's auxiliary equation. Now this is the second degree equation. am squared. My variable is m. We need to solve the equation for m. So we have two roots. And for the second order or second degree equation, or quadratic equation, we have three cases, depending on the discriminant of the quadratic equation. If the discriminant, which is b squared minus 4ac, this is the discriminant. If it is greater than 0, then we have two distinct real roots. We are going to have two different solutions for the quadratic equation. And if the discriminant, which is b squared minus 4ac equal to 0, then we have one real solution or one root, but it is with multiplicity 2. You can say it is duplicated. It's like when we say that x squared, for example, to power 0, then I have x equal to 1. This is the root for this equation, x minus 1 to power 2. But we know since it is a quadratic, I can say this is x equal to 1, which is equal to r1 and r2. The two roots will be the same. They are not different. For the third case, if the discriminant is less than 0, then we are going to have two conjugate complex numbers. Two conjugate complex numbers. This will be the solution for the auxiliary equation or for the quadratic equation. Now let's have some example to explain how to write or how to find the general solution of the differential equation. Suppose that we are given this equation or second order differential equation, and we need to find the general solution of the second order differential equation. I have 4y to power, or the second derivative plus y prime equal to. The first step, we are going to write the auxiliary equation for this equation. The auxiliary equation is equal to 4m squared plus m equal to 0. If we replace e y by e to power m x, then as we said, y prime equal to m e to power m x, and y double prime equal to m squared. Again, if we go back, we need this equation, the auxiliary equation. If we remove this e to the power mx, so the remaining will be the auxiliary equation. Or in some textbook, they are saying it is characteristic equation. Auxiliary or the characteristic equation. Now I have 4m squared plus m equal to 0. Now we need to solve this equation. I will take m as a common factor. Then we will have 4m plus 1 equal to 0. So either m equal to 0 or 4m plus 1 equal to 0, which means that m will be minus 1 over 4. So these are the two solutions for this differential equation. Either m equal to 0 or m equal to minus 1 over 4. So the general solution will be y equal to c1 e to power m1x plus c2 e to power m2x, which is equal to c1 e to power 0 plus c2 e to power minus 1 over 4x. We can say y equal to c1 plus c2 e to power minus 1 over 4x. So this is the general solution for the given differential equation. The second example, we have y double prime minus 3y prime plus 2y. We do the same thing. I'm going to write the auxiliary equation for the given differential equation, which is y prime will give me m squared minus 3y or 3m. Y prime will give me m plus 2 equal to 0. So what? Solve the given quadratic equation. By factoring, this can be written as m minus 2 multiplied by m minus 1 equal to 0, which that will give me either m equal to 2 or m equal to 1. So we have two different or two distinct roots for the quadratic equation. Now the general solution will be given by y equal to c1 e to power m1, which is 2x, plus c2 e to power x. So this is the general solution for the given differential equation. One more example. Y double prime minus 10y prime plus 25y equal to 0. The auxiliary equation for this one is equal to m squared minus 10 m plus 25 equal to 0. By factoring or by initial identities, this can be written as m, say, by factoring it is m minus 5 times m minus 5 equal to 0. Actually, this is perfect square. So we cannot just write it as m minus 5 to the power 2. Just put it in this way. We want to say that we have same root for the equation. m1 and m2 will be the same. So m1 equal to 5, which is equal to m2. Because if we check the discriminant for this one, which is b squared minus 4ac, that will be equal to 10 to the power 2 minus 4 times 25 will equal to 0. So we have duplicated or a root of multiplicity 2, m1 equal to m2. If we have this case, then the general solution y equal to c1 e to power 5x plus c2 e to power 5x. But if we write it in this way, e to power 5x plus c2 e to power 5x, then the two solutions y1 and y2 will not be linearly independent. Actually, this part, for this one, we have to multiply the second one by x to make them linearly independent. So if we have similar rules for the auxiliary equation, the second solution must be multiplied by x. We can say in general, the solution is equal to y equal to c1 e to power m1x plus c2x e to power m1x. So that we have the same rules. So this is the general solution if we have a root with multiplicity 2, c1 e to power mx plus c2x e to power m1x or m2, because they are similar. So it is just y equal to c1 e to power mx plus c2x e to power x. One last example, if I have y double prime minus 4y prime plus 5y equal to 0. Then for this case also we are going to write the auxiliary equation and find the solution for this one. And we will see for the given equation, we will have two complex roots. So let's write the auxiliary equation and find the root for that one. So the auxiliary equation is m squared minus 4m plus 5 equal to 0. Now to find the root, this is cannot be factored. So we can use the quadratic formula to find the root for the given equation with that m equal to minus b plus or minus the square root of b squared minus 4ac divided by 2a, which is equal to minus 4, or minus 4 is equal to 4, plus or minus 16, minus 4 times 5 is equal to 20, divided by 2. This will give me 4 plus or minus square root of minus 4 divided by 2, which is equal to 4 plus or minus 2i divided by 2. It is 2 plus I, or plus or minus. This can be written in general as alpha plus I beta. I need to write it in this form because the general solution, if we have complex, will be e to power alpha plus cosine beta, sine beta, or cosine beta alpha plus sine beta, like this. So if we have complex, then the solution for this case will be y equal to, well, let me say that alpha is equal to 2 and beta equal to 1, the coefficient of this one. Okay, plus and minus. I need just to take alpha and beta. Now the general solution, if we have complex, will be y equal to e to power alpha x multiplied by c1 cosine beta x plus c2 sine beta x. This is the general solution if we have complex solution. So the equation now, or the solution, can be written as y equal to e to power alpha is equal to 2, beta equal to 1. So it is e to power x multiplied by c1 cosine beta is equal to 1x plus c2 sine 1x. So this is the general solution if we have complex root for the auxiliary equation. M1 and M2 are conjugate of the complex numbers. Then the general solution is y equal to e to power alpha x multiplied by c1 cosine beta x plus c2 sine beta x. So this is how to find solution of linear or second order linear differential equation. Just write the auxiliary equation, then find the root, and then write the general solution.